Today we will solve problems using data represented in circle graphs, including part to whole comparisons, and equivalence. Mr. Brown planted a vegetable garden. The circle graph shows the kinds of vegetables he planted and the percentage of the area of the garden each kind of vegetable occupied. Mr. Brown's garden has an area of 160 square feet. How many square feet of Mr. Brown's garden is occupied by cabbage? So first we'll start off our problem solving by identifying the important information. So it shows the kind of vegetables he planted and the percentage of the area that each vegetable occupied. Then they also tell us that his garden has an area of 160 square feet. How many square feet is occupied by cabbage? So I'm going to circle how many square feet occupied by cabbage. So like some of the problems that we've been doing recently, we're making part to part or part to whole comparisons. Here it tells us that Mr. Brown's garden has an area of 160 square feet. So it's telling us if this circle here represents his garden, that would be 160 square feet. So they give us the whole. Whenever we're solving these problems, we want to ask ourselves, is the problem asking me to make a part-to-part comparison? For instance, a part-to-part comparison here might be comparing string beans to broccoli, because those are parts of his garden. But here, they want us to compare the amount of square feet occupied by cabbage, right? Because we don't know the cabbage area compared to the total area of the garden. Now, this particular problem, they give us the percent. We're going to have to find out what numbers or what value represents those percents. We're going to have to figure out what area cabbage represents. Now, the first step is we have to identify the whole. Now, it tells us that here that the garden has an area of 160 square feet. So we're going to say 160 square feet is the whole, right? Then the next part is we're going to have to find the percent. Percents represent a part of a whole. Now, in order to represent the part of the whole, we have to think back to what we know about percents. So for this circle graph, if we were to add up all of the string beans, broccoli, lettuce, carrots, and cabbage, if we were to add up all those percents, then those percents should be 100%. So 160 square feet is the same thing as saying 100% of his garden. Now, in order to figure out the percent represented by cabbage, right, we have to figure out what the percent is here, because we know the percents of all the other areas, the carrots, lettuce, broccoli, and string beans. We're just going to add up all of those. So we'll add up the broccoli, 45. We'll add the lettuce, 25. We'll do the carrots, 5. And we'll do the string beans, just 10. So we'll add all those up. 45 plus 25 is 70. 70 plus 5 is 75. 75 plus 10 is 85. So all the percents, we're talking about all of this. All of that represents 85% of the area. So what's left over for cabbage is 15%. So we identified the whole. Next, we're beginning to find the percent or part of the whole. So there's two ways that we can do this. Now that we know that cabbage represents 15% of Mr. Brown's garden, we can use the percent proportion, right? So we call this in class, when we would do this in class, we'd call it 4 lines and an equal sign. And then our first ones are for labels, part to whole. Our last ones are for labels, percent over 100. Now, some of you guys remember the percent proportion in a different way. As long as you kind of have the gist of this, this is fine. So we're making a part to whole comparison here. And we have to ask ourselves, do we know the part or do we know the whole amount? Well, we don't know the part yet. We don't know the number of the feet represented by cabbage, right? So if you want to think about it, this is cabbage over the total area. So we know that the total area is 160 square feet. We do not know the part or the area that the cabbage covers. We know that all percents are out of 100. And then we just did the legwork and we just figured out that cabbage is 15% of his garden. So now we set up the percent proportion, and you can pretty much set up all of these problems to solve using the percent proportion. The way that the percent proportion is, you set it up 4 lines and an equal sign like we just did, and then you plug in all the information that you know. Do you know the part? Do you know the whole? Do you know the percent? And then we know that all percents are out of 100, so we can always put this 100 here. 100 will always go there when we start setting up this percent proportion. And then from there, we're just cross multiplying, right? So 100 times x is 100x equals 160 times 15, which is 2400. And then we're solving for x now. So in order to solve for this one-step equation, we're going to divide both sides by 100. And then we've talked about it before. Whenever you're dividing and you have zeros in your numerator and denominator, you can simplify or cancel them out. So 24 divided by 1 equals 24. So then we have to think about what 24 what. So if we look back to our percent proportion, we remember that our x here, we were trying to find out the part of the area covered by cabbage. So you see there, b equals 24. Now that's one way of doing it. That's method number 1. So if you understand using the percent proportion and this way works for you, then I want you to use this every time if you can. Now I'm going to erase this, and then we're going to go to method 2. And I'm going to show you a different way to finding percent of a whole, or a part of a whole. Now here, whenever we're trying to find a percent of a number, now in class, whenever we went over these, we always said that the word of and a percent of problem tells us that we're going to multiply. So we're going to multiply the percent. We found out that cabbage was 15%. We did the legwork for that. So 15% times the number, or in this case, we're talking about the whole, percent of a whole. It was 160. And if I multiply 15% times 160, I can't multiply 15% times 60 first. We're going to have to convert this percentage into a decimal first. Now, in order to convert a percent into a decimal, we would divide by 100, or most of us remember Dr. Pepper. We're going from percent to decimal, which means we're going 1, 2 spaces to the left. Here, we're going to go 1, 2 spaces to the left, which gives us 1500ths times 160, or 0.15 times 160. And if you multiply those two, you get 24, right? Which means that there's 24 square feet occupied by cabbage. So we just saw 2 different ways of solving the same problem. First of all, we recognize that this was a part to whole comparison. We're trying to find out the part, meaning cabbage, or the area of the square feet area occupied by cabbage compared to the total garden. We did that. First of all, we set up the percent proportion, the 4 lines in an equal sign, part to whole equals percent over 100. We cross multiplied and we solved a one-step equation. And then the other way of doing it, method 2, is the last one that we just did. We found the percent of a whole, or the percent of a number. We took the percent and we multiplied it by the whole. Well, before we could multiply the percent by a whole, we had to convert the percent to a decimal. We multiplied it, and it gave us our whole amount.